In this example, we're given that slope field that we took a look at in example 1, and we also have the differential equation dy dx is equal to x minus 1. And here what we want to do is we want to sketch the solution curve through the point 1, -1. So 1, -1 is down here. So we know this is a point that's on the original graph or the solution to this differential equation, which is going to be y is equal to. You can also try to find the antiderivative like we did before. So check out that video on example 1 if you'd like to know how to do that. More on that in a later lesson. There's definitely some things that we need to look at. However, for this example, we just want to sketch that solution curve. So what we're going to try to do here is we're going to imagine that even though we just have a few of the slopes, we want to imagine that actually we have every single slope to this solution curve. And what I want to do is I want to try to draw that solution curve that passes through this point, keeping in mind that for any x value here where x is 2, my slope, you can tell, let me try to change the color for you here. Even though we're not going through one of the other points, there's lots of other points, right? In between the ones that are just graphed. And we know here vertically that when x is 2, the slope of the tangent line is still would be 1 there. And I want to try to draw the curve that fits that, even though it doesn't pass through one of the ordered pairs that's on the graph here, like one of the dots. And as I continue to draw this curve to the right, it's going to look a little something like this. As I do the same thing here to the left-hand side, I'm going to do my very best to draw this curve, and I need to try to match the curve to the slopes of those tangent lines as I come up. Notice here, and this upper left-hand part's a little bit off right there, but you can see that if we had to, change colors for you again, if we had to draw a tangent line right here, that tangent line would have the same slope as the other ones. This, to me, looks quadratic, and if we took the antiderivative of a linear function, which we have here is dy dx, that's our differential equation. So if we had the antiderivative of that linear function, we're going to get something that's actually quadratic or does look like a parabola. So keys with this particular example are to make sure that your curve goes through the point that it's supposed to, and then try to draw that curve that matches with those tangent lines that you see.